Well, thank you all for being here. I know a number of you are probably a little bit afraid because I'm going to be talking about math, and that scares a number of people. I think the translators are going to be particularly afraid. They thought probably they were done with having to do this when they left school, but they're going to have to deal with a little bit of math, but it won't be much. And to share the fear, I'm going to give a live demo, so I'll be a little bit afraid also. My outline is I'm going to be talking about the big picture about math accessibility. We've heard a lot about it as an overview. I'll get to more detail. I'm really going to focus in on equations, though, today. That's my main focus for today. And I'm going to talk about what works today. And then I'm going to give a demo, just a really quick demo for those of you who want to come later to the main demo session. You can sit down and we can do stuff together. So. Why math? And it's because every day, every child takes a math course. It's not wild-haired professors writing on chalkboards and scary movies. It's in the United States, we say it's one of the 3 R's, reading, writing, and arithmetic, which kind of shows we don't know how to spell, but today, it's very slow and expensive to get, say, an embossed version of a textbook. It takes about 6 months and $60,000, so a born digital book is a much cheaper, much faster option. But it's not just about blindness. So people with certain cognitive disabilities that are related to vision, such as dyslexia, they have 2 times the error reading rate as someone who's reading text that has dyslexia. So it's an even bigger problem to read math than it is for text. So it's an important area for a lot of people. So I'm going to start with sort of what most people think about when they have to do math, which is I got a calculator, I do some calculations. And there are some accessible calculators. What came out recently and is very popular in the United States is an addition to the TI-84 calculator. That's a test calculator that can be used on the high-stakes standardized tests. And so having this little module that you plug into it that will speak what you're typing. It'll tell you some things about the graphing that happens on it. That's been a really popular thing. Another area is diagrams, because you have math, like in a geometry book, you'll have a picture of a triangle and the sides, as Betsy showed, A, B, and there'll be a little angle for a right angle in there. And so those need to be made accessible, and Betsy talked a little bit about some challenges there. So I'm going to focus more to the math side of things, where you have a lot of plots. And the simplest solution for dealing with plots, well, plots are a set of numbers. And so you can have a table, and you can just read the table. And that's a very low-tech way of doing it. For those with sight, I think everybody knows that a table of numbers is not a really good way to understand what the numbers are doing. We like to see them. So tactiles, as has been mentioned, is a great solution. That's, again, a sort of an older, lower-tech solution, and some higher tech additions have come along. So if a computer generates a tactile, you print it out or you emboss it, and you stick it on, say, a touchpad, well then the computer would know when you press on it where you are on that tactile. So it could tell you more information, like what the x-axis really means, because that may not be fit in Braille. Or it could tell you about the exact value of a point when you touch it and feel it on the tactile. And along that similar idea is, instead of a touchpad, another system has a camera that's mounted up, and it's looking at where you're pointing your finger. So again, it knows where you are, and it can give you some more information. And the last idea that's been around for a couple of years, and Betsy touched on that, is sonification. So I have an example here. This is a program called MathTracks, and I typed in an expression there. It gives you some verbal text, which will be spoken about interesting things about the plot, but it also can sonify it. And so this is going to produce a sound, and as it moves across the x-axis, if you wore earphones, which you would in a class, the sound will move from left to right across your ears, and you'll hear the frequency vary. And then it will do a few things at interesting points along the way, and in particular, you'll hear some background noises whenever it's below the y-axis. So let me go ahead and play that. So you can tell that as the frequency goes up and down, you get a sense of what that sounds like. So that was a line plot. So this is what's called a scatter plot. And this comes from a book that's a free book for iPads on the Apple Store. It's called Exploring the Solar System, or Exploring the Universe, Touch, Look, and Listen. And this is a video of a blind person using this. And what they're going to be doing is exploring a little bit on the axis to get some idea of what the axis lines are about and what sounds it's going to make. And then they're going to actually hear some of these lines, sort of scattered plots. And just to give you a little astronomy background, a hot star has a different color relationship. And so again, it sweeps from left to right on the x-axis and different tones for the temperature. So let me go ahead and play this.
Y equals the brightness of the sun. Double tap for sonification.
This is an iPad, by the way.
Y equals 1,000 times brighter than the sun. Double tap for sonification. Y equals 1,000. X equals 8,000 degrees Celsius. Double tap for narration. Use the rotor to access links. Blue giant, 24,000 degrees Celsius. 210,000 times brighter than the sun. Blue giant. Red giant, 3,100 degrees Celsius. 29 times brighter than the sun. Double tap. Red giant. Main sequence star, 20,000 degrees Celsius, 120 times brighter than the sun. Double tap for main sequence star.
So that was, again, someone who is blind using this on an iPad. And that's an entire book on astronomy that you can, that's fully accessible. So now I'm going to move on to the main part, which is about about equations. And what most, as has been alluded to, what most people do in the past, it's starting to change now, is they produce an image. And the reason you do that is it works everywhere if you're sighted. This is an example of an image. It's pretty complicated. Actually, trying to listen to alt text can be a problem. But we all know that with images, the solution always is alt text. That's what people use today. For math, bad idea. And the reason why it's a bad idea is because for math, there are separate Braille codes that aren't derived from the text. So you can't do that if you just have alt text. If you need to magnify the image for someone who's low vision, that doesn't work. For people with dyslexia, as the math is being read, it's very useful to highlight that part of the expression. That really helps the comprehension. You can't do that with alt text. And you want, for a big expression, you want to be able to move around and explore the expression, just like you might want to move around a table. And they call that navigation. And again, with alt text, at best, you can move around word by word, which is, for a longer expression, not very useful. So what's the solution? MathML. You've heard it a few times. You're going to hear it a lot from me. I think a number of my friends refer to me as Mr. MathML because I'll say MathML, MathML, MathML over and over and over. It works in some of the browsers. It works in Firefox. It works in Safari. And it used to work in IE with the free download math player from my company, Design Science. But that depended on, it was a plugin, and IE has removed plugins. So that's kind of fading away. You have to use IE in a legacy mode, and that creates some problems. It still works, but it's getting less and less useful. Thankfully, there's a solution. There's a JavaScript library called MathJax. If the author includes it in their page, then it will display the MathML just beautifully, and there's no problems. The only downside is that it's a large download, and it also slows things down because it's JavaScript. But the math does display, and it becomes accessible. MathML is used by almost all math applications. It can be imported or exported from them, so it's widely used there. And the great news is that it's recently had a lot of acceptance from assistive technology vendors. So if you have an Apple device, VoiceOver or Safari, VoiceOver plus Safari will work on that, and will read the MathML in a web page. If you have a Chromebook, Chromevox, which is a free download, and which Victor Sorka wrote, will work on the Chromebook. And if you have a PC, the latest version of JAWS 16, will read MathML, as will the new version of Math Player, which I'm going to talk about in a little bit. MathML shows up in standards. We've heard about it. It was in DAISY 3. It's in EPUB 3. It even is part of the PDF UA standard, and I'll mention that a little bit more briefly. On the web, you can configure Wikipedia to produce MathML so that all that Wikipedia pages out there that have math, they're going to be accessible. You do need to sign in and set it. Eventually, it'll become the default. In the US, we have I'm not sure how much it's been translated, but Khan Academy, it's a very popular tutoring site. It has a lot of videos about math and science, and they have the exercises are fully accessible in math. A number of learning management sites like Stack Exchange and Moodle, they use MathJax, and so you can make that accessible. And some of the publishers now, Pearson is starting to put out their textbooks with MathML, and Elsevier on their scientific journals with ScienceDirect uses MathML. So I want to talk about Math Player 4, which is the latest release. It came out in March. It's a library that can work with all of the assistive technology out there. It has the ability to customize the speech based on the disability, which come to the demo, and I'll talk about that more. It put out Braille for refreshable Braille displays. It'll do it can help with the synchronized highlighting, and it can do navigation. NVDA, the free screen reader, works with it, and it works in Firefox and IE, and it works in Microsoft Word and Microsoft PowerPoint, and it even will work with a PDF document if you could find a PDF document that has MathML in it, which you won't be able to find. So not so useful there, but someday it's ready, so that part of the chicken and egg problem has been broken. We're just waiting for the tools to write that. Also, if you have window eyes, it'll work with Word there. And text help, they haven't released it yet, but it works in all the browsers with text help. There's a lot of features in Math Player 4. You can set the speech for the disability group, as I mentioned, verbosity. So if you're an expert, you want a more terse speech, and if you're a beginner, you want more words spoken. It supports 15 different languages, somewhat varying degrees of support. Not all the language translations are up to date. And it has subject-specific speech because sometimes the same notation is used differently in different subjects. It also supports navigation, so you can move around an expression. You can do it in 3 different kinds of modes of moving around. You can get a reading of the expression or an overview, so it might be the sum of 3 terms or something like that. And you can set place markers, so if you need to cancel things, you can say, oh, I want to remember there, 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 and there, and move around or just listen to what's at the place marker, and if you get lost, you can ask, where am I? So now I want to do the demo, and I hope this works. So this is a Word document. This is math that's done by MathType. And I'm going to go, just to prove that this is live, I'm going to go and edit this, and I'll make this a square root, say. Square root. So it's a WYSIWYG thing. So there we go. I added a square root. I'm going to put it there. Now, all the time I've had NVDA turned off in the background, so I'm going to turn it back on.
Speech mode beeps. Speech mode talk.
Okay, so I just changed that.
Heading level 2, page 1. Find the sum. Fraction, the square root of x plus 1 over x end fraction plus fraction x over x minus 1 end fraction plus 2.
So that was live. I just changed it. I didn't have to do anything special as an author. It's just reading it in the Word document. Now, a warning to the translators, I'm going to switch to French, and this is because I don't speak it. I'm going to let the computer do the speaking.
PowerPoint slide. Racine carry Wikipedia Mozilla Firefox. Racine carry Wikipedia document. Main landmark list with représentative admet une demi. Link toujours vertical. Sa link fonction dérivée est donnée par.
I'm hoping this is saying something.
Out of list with 1 items. List with 1 items. Le premier dérivé de x en ce qui concerne racine carrée de x égale fraction 1 sur 2 racine carrée de x. Fin de fraction.
Okay, so that's the limit of my French, and I hope it was right because I really don't know.
Homework. PowerPoint slideshow state of accessible N.
Oops.
Slideshow slide 18 when you create
So if you're creating math, there's a standard workflow that a lot of disability student offices use in the United States, which is to start with a Word document. And you could, and then from there you can produce a large print document easily by scaling the math and the rest of the text. Or there's two tools to produce embossed Braille, Duxbury's Braille Translator and ViewPlus's Tiger software suite, so you can get embossed Braille out. Using the math type and math page program that comes from my company, Design Science, you can produce a web page. And so the web page then is a fully accessible web page using Math Player or some other tool like JAWS. Or, as you just saw, you can just leave it as a Word document and send it to the students or publish it, as is. And so
slideshow slide up.
My last slide, I want to say that there's really a bright future. Things have really improved dramatically in the last couple of years. Many sites are now accessible. Many AT vendors now support the math. There's still some work to do about authoring and solving and touch, making that accessible. And there's certainly some little tricks you need to know, such as logging into Wikipedia and setting it up properly. And so the final thing I want to come away with is images are bad. Don't use images with alt text because of all the problems. You can't magnify them, you can't navigate them, you can't get Braille out, the speech is not customized to someone's disability. And the last thing I want to show, which leads on to what Volker's going to talk about, is a chemistry formula. And I hope that this demonstrates why navigation is so important. So let me get to
bullet authoring, bullet image, bullet come to demo, 6 CO2 plus.
And we must stop. We are very late.
Okay. Well, I'll come to the demo and I'll show you why that was so useful. Than what Betsy did. I want to show a couple things real quickly, just maybe 2 minutes. I'm going to need sound again, so please turn the sound on for the computer. And then I want to open it up to questions from the floor and have some interaction and see what kind of questions people have. And I'll demo them and show what's what and hopefully answer whatever I didn't get to. So I want to start by finishing off this chemical equation. So I know a lot of you might look at the chemistry and say, I don't understand this, I don't know what it is, but I want to show the power of being able to navigate and break things apart into small pieces and show that it really will start working. So let me turn NVDA back on.
Speech mode off. Speech mode leads. Speech mode talk.
Okay, so I'm going to start by doing the navigation here. I'm going to move into navigation mode.
Math 6 CO2 plus 6 H2O
Okay.
with energy yields C6 H12 O6 plus 6 O2.
So this is Math Player reading a chemical formula. It sounds somewhat complicated, but now I'm going to start to navigate it. And I use the down arrows to move in to smaller pieces, left and right arrows to move left and right. So I'm going to move in
zoom in
twice.
6 zoom in 6
so that's 6 of something. I'm going to move to the right.
CO2.
Well, CO2 is probably something we all remember, carbon dioxide. So we have 6 carbon dioxides. And if I move to the right, and let me,
plus 6 H2O.
So again, H2O. We have carbon dioxide and water, so we all know that.
With energy yields.
So we're throwing in some energy into this system.
C6 H12 O6 plus 6 O2.
Okay, so the first part, maybe we don't understand, maybe some of you recognize it, but O2, that's oxygen, and there are 6 of them. So, you can start to think about, well, we had some carbon dioxide, we had some water, we threw in some energy, and I'll give you a hint, it's sunlight, and we got some oxygen coming out plus something else. That's photosynthesis. So you can really kind of build that up from the little pieces, which when you start and hear it all at once, you can't really hear. So that type of exploration works for math also. I want to show one other thing here, which is a little bit of a tease.
From Adam MW11, from Adam MW11 student resource sample, 1/5 is equal to rise over run.
So as I said, this is NVDA.
Optimal resolution notification.
This is NVDA, and this is a PDF document. This is a little snippet of a math textbook that somebody converted by adding some MathML to it. It takes an expert to do it because the tools don't generate it themselves, but I wanted to just show, I'm going to go up a line just to do one more example.
20/100 is equal to rise over run.
If I had a Braille display, the Braille would be on the Braille display, and I can go ahead and navigate that again.
Math 20/100 is equal to,
So let me
zoom in numerator 20,
and if I go to the right,
in denominator 100.
and so forth. So that's all I wanted to show right off the bat that I didn't show in the original talk, and I want to open the floor to people with questions about math conversion, how do you create it, whatever sort of I didn't communicate well at the beginning or didn't talk about at all. Please ask, otherwise if there are no questions, I'll let Volker. So I don't think we have someone running around with a speaker, so just speak loudly. If you speak French, hopefully the translator will pick it up.
I speak French, yes. Bonjour, je suis Hélène Ménard, je suis enseignante-chercheuse à l'Université Paris-Sud et animatrice du groupe de travail handicap de
So the interpreters can't pick it up. So Dominique, if we could. I knew the math part would scare the interpreters, so.
Oui, donc bonjour, je me présentais, je suis enseignante-chercheuse et je m'occupe du handicap pour l'Université Paris-Saclay. Et donc nous faisons dans l'Université Paris-Saclay beaucoup de publications scientifiques. Et toutes ces publications scientifiques sont réalisées la plupart avec la tech. Donc est-ce que tout à l'heure vous avez fait une démonstration de Word, de conversion de Word vers MathML avec des formules relativement simples. Donc est-ce que avec des formules compliquées, comme on peut en trouver dans les publications scientifiques des universitaires écrites en latex, on peut avoir un résultat intéressant, sans erreur, et même quel type de résultat, dans la mesure où parfois les équations mathématiques sont difficiles à énoncer, même pour un être humain.
That's a really good question. So let me start with I'm going to go work backwards. So I'll start with the can it do hard math, essentially college level math? And the answer is, turns out the more high level math you get, the easier it is to do. When you go way down to elementary school math where you have a long division and it's spelled out, or you have stacks of numbers and there are carries and borrows and crossouts, that turns out to be hard to read. In fact, I'd put up a challenge and see if anyone could actually tell me how you want to read something. You could see what's going on. But when you get to high-level math, if you have an integral, the integral is easily spoken as the integral from 0 to infinity of e to the minus t or dt or something like that. That's actually relatively easy to speak. It's not hard to enter into the systems. And so actually that's not too bad. Where the complications come a little bit is that sometimes notations are used the same in different subject areas. So if I put an x with a bar over it, the top of it, in statistics that would be the mean of x. In maybe algebra, that might be the complex conjugate of x. And so with Math Player, we'd love it to be able to know the context. But since it's not smart enough to do that, and I wasn't smart enough to program it to do that. You have to tell it, I'm doing a calculus book, and then it'll read the calculus notations. Again, like an x dot, which is a Newton's notation for a derivative. You might speak it as x dot in a normal sense and maybe in a terse form, but for someone first learning, you'd want to say the first derivative of x or something. So it knows about that when you put it into calculus mode. So to step back a little bit in terms of LaTeX input, there are some converters. They have some issues converting LaTeX to MathML in some cases. They're not bad. You can actually type LaTeX into a Word document with math type, and it will convert it, and you see it right away. If you're blind, one of the problems with LaTeX is you can learn it, but if you make a mistake, you don't know you have a mistake because you won't be able to see the results. And so one of the kind of nice things about typing it into Word is you convert it right away into the MathML, or actually into the math type. It displays it nicely, and then it's read to you. So you can hear whether you got it correct or not. And again, the complexity of that, it becomes hard to listen to all at once as you get to big and bigger expressions, but you can break it down and you start navigating it. Also, you can get it on your Braille display. So if you are proficient Braille reader, which unfortunately there are not a lot of proficient math Braille readers out there, you could read it there. And those who are proficient at it really prefer the Braille that I've heard about. So we have some more
Il y a une autre question ici. Oui, c'est bon.
Thank you. Abby James from University of Southampton and British Dyslexia Association. I've got two questions. Firstly, on the demonstration you gave, you showed working with Word with math type. Mm-hmm. We have in university, the materials may be created using math type, but the students, when they get them, don't have it installed. Is it reliant on math type being there?
It is reliant on math type being there. I think, so the original idea when we did this is we thought math type needed to be there in the full version. Yeah. What happens is if you download the version, you get a 30-day trial, and after 30 days it reverts to a light version.
Okay.
I was told, and I haven't verified this because I actually have a real version and it hasn't expired, that it keeps working. It wasn't the original plan, but I believe it keeps working. And one of the things, I didn't show that. Hold on a second.
PowerPoint, trigonometry, homework not confined.
So as I said, this works with NVDA and Window-Eyes right now, where we expect more vendors to join on. JAWS has done their own math, and they don't work with Word, but up in the upper corner here, we have some accessible buttons. So in JAWS, it'll read, and it'll be some garbage-sounding thing for the math, and you can stop it and then use the buttons to go and self-voice the math or navigate the math. So even if your assistive technology doesn't directly work with it in a nice way, it's not a bad document. You can still get stuff out of it.
And just with my other hat on from the British Dyslexia Association, my colleague's going to be talking this afternoon about the exam situation in the UK where we use PDF documents. Can I just ask, are you talking about PDF UA specification there, or is it general PDF specification will support maths in the future?
So it's a kind of a wishy-washy answer. PDF is at it's called ISO 32000-1. And there's in the pipeline, it's in a draft standard at the moment called -2. Associated with -1, there's a PDF UA -1. And also in the pipeline, there's a -2. Because of technical ISO standards, -1 for the UA document could not reference MathML because it wasn't mentioned in the 32000-1. However, the technique that we already had developed will be in -2, will be referenced in PDF 32000-2, and it works today. It will be the same one that NVDA is reading in the document. The problem with PDA versus, say, an HTML document is you can't sort of open it up and say, oh, I'll just tweak this or I'll just add that. It's very difficult. You usually need some specialized tool, that's how that PDF document was created. It was by one of the remediation experts with PDF, and they went in there, and I don't know, I would have thought it was a nightmare to do it, but they were able to really, he said it took them only a day to do the first chapter of some book, and I was really stunned that he could do a whole chapter in a day, but he said he has good tools, so it is possible, but it's not for the faint of heart.
Thank you.
A very quick last question, please. There is two.
Bonjour, Françoise Mania, présidente de la Commission pour l'évolution du braille français. Vous avez parlé de la possibilité de mettre ça en braille papier. Or, au niveau du braille mathématique, nul n'ignore que pour ne pas être international, ça ne l'est pas du tout. Donc, est-ce que votre système permet de le transformer en braille mathématique papier, quel que soit le braille mathématique? Donc, moi, je parle pour ma paroisse, pour la France, mais je peux penser aux autres. Donc, est-ce que ça peut être en braille américain? Je ne me fais pas de soucis, mais en allemand, etc. Merci.
Let's see. The translators that work with Word are the Duxbury Braille Translator and the Tiger Software Suite. So the Tiger Software Suite makes use of an open source library called LibLouis, and it currently supports, I think, 4 different Braille math codes, and I don't believe French is one of them at the moment. The Duxbury translator is a more, more robust. It's been around a lot longer. I think it supports French. Somebody in the audience probably could correct me and tell me exactly what it supports. But it supports many more math Braille codes, and so it could be, if indeed it supports French, yes, the conversion would be appropriate for French in the math Braille code. We also make use of the LibLouis library for the refreshable Braille display, and so we're limited to what they do, and that's 4 different Braille math codes, which is not French at the moment. But it's an open source project, so if someone contributes the conversion, it will show up in our product, and it'll show up in other products too.